What's up guys, welcome back to another video. And in this video we are going to talk about you probably read the title of this video already, but anyway, we are going to talk about the BLoC design model. BLoC stands for business logic component, and this has been the trending topic recently in the world of Flutter. Suddenly in the world of Flutter, BLoC pattern was first discussed about in the Google I/O event. I think in the 2018 Google I/O event, this BLoC pattern was first discussed about. It's nothing but pattern, not exactly, but it's writing reactive mobile applications using Flutter, guys. That's it. In simple words, it's writing reactive mobile applications using Flutter. So how exactly are we going to be doing that? We are going to use the concept of streams. Okay, streams are nothing but, as I already talked about that in another video. I think it was in the HTTP video, I think, or the list video. Streams are nothing but values arriving over a period of time, values or events happening over a period of time. If you are already familiar with, if you are a long-term watcher of this channel, you would obviously know we cover a lot of topics on RxJS, right? Reactive extensions for JavaScript. Exactly, that's exactly what we'll be dealing with when we bring in reactive programming inside Flutter applications as well. Okay, we have a separate package for that called Rx.dart, which we'll be using, and these streams are the ones that play a major role in this entire BLoC design pattern. So what exactly is this pattern, and why is it used? People say that it's used for maintaining state in our application, right? How exactly is this done inside the Flutter apps? Let's see that. I wanted to do an animation for this, but turns out that I'm really bad with whiteboard animations. So I thought I'll spread a chart out here and then record me drawing some stuff on that. So let's move to that. So what exactly is this business logic component or the BLoC pattern? So BLoC pattern stands for, as I said, business logic components. Okay. In simple terms, it's something like a pattern to maintain state in your application, thereby enabling you to write reactive applications. So what exactly is that? How to break it down in a simpler way? In a simpler way, assume that this is the business logic of your application. This box contains the, is it visible? Yeah, it's visible. This box contains the business logic of your application. Whatever you want to do, the calculations, the processing, whatever you want to do with regards to your application, with regards to your purpose of building the application, is present inside this business logic. Okay, this is a business logic component. Okay, and there are multiple inputs arriving to this particular business logic component. These inputs are nothing but streams of events, right? Say for instance, a user tries to add a particular user to this application, or a user tries to change his profile picture, or a user tries to change his status, something like that. All these are events that are appearing over a period of time, hence they are called streams. There will be multiple streams. Stream, before talking about this, a stream is nothing but data or something that's appearing over a period of time, guys. Say for instance, you have two variables A and B, okay, and you're adding those two to give C. Okay, so say for instance, in this A is 2 and B is 3, so C will be 5. C is the resultant data, that will be 5, right? Is it visible? I hope it's visible. Yeah, it's visible. 2 plus 3, 5, right? So for instance, this B changes to 5. In this case, C becomes 7, right? And A changes to 6. In this case, C becomes 11. Now B also changes to 6. C becomes 12. So C was 5, and then it was 7, and then it was 11, and then it was 12. This is C. C is appearing over a period of time. So this is a stream of values, right? So this is what a stream of events is, what is sent into a business logic component. And as usual, a stream of data is given out as output from this. Probably use a different color maybe. And a stream of output data is given off from this business logic component, which is the actual processed data. This processed data is then transferred to the listener. Whichever widget is listening to this particular data will take up this data, listening to this particular stream will take up this data and use it accordingly. Say for instance, show it upon the screen, throw it upon the screen, or do something else, throw a notification for the user changing that, saying that his data has been saved or something like that. This is BLoC pattern, business logic component pattern. Very simple explanation of this. We are using streams completely to maintain state throughout the application. Each and every logic or each and every processing that we do inside the application are termed to be separate business logic components, and all the events are sent to these components as input, and the process data is taken out from these components as output. Then there are specific listeners listening to those particular output streams, which are then notified or which then update the state of the application accordingly. That is whatever we have programmed whatever we have programmed those listeners to do, they'll handle that state change accordingly. This is exactly BLoC pattern in simple terms. All right. Now why should we use this BLoC pattern? That is an important question, right? Why should we use this BLoC pattern? So this is mainly, this is mainly used to maintain state throughout the entire application, right? Maintaining state across a large application becomes a tedious task if you are really into programming, guys. Old school programmers would obviously know this. For little applications, that is for small applications with a few users, then you don't need to maintain state or anything. But as you scale up, you need to look at state from a clear perspective. You might wonder, is there any simpler way to maintain state other than these streams and all these concepts? Yeah, there is a simpler way. We can use something called inherited widgets. As I said before, in Flutter, everything is a widget. So to maintain state across, say for instance, the user changes the color of a particular component, and that color change needs to be maintained uniformly throughout the application. So in that case, one thing you can do is, this is a widget tree, right? Here you can maintain the state. In a particular widget, you are maintaining the state, and say for instance, this widget is an inherited widget of this particular state. That is, it uses the context of the application of the inherited widget state. So whenever a change occurs in this state, it gets notified here, and this reflects that particular change as well. Say for instance, this is also using the context of this inherited widget to modify its state. So this is what inherited widget means. It's really easy and simple to use, and it can be used for small applications. The reason why I am not saying this can be used for large applications is that this is completely not visible, right? Wait. The reason why I am saying this cannot be used for large scale applications is that whenever a state change occurs, then all the listeners that are listening to that particular state change will get rebuilt, right? Say for instance, this state will affect this particular listener and its handler, whereas it will not at all affect this particular listener and its handler. Assume that. But whenever a state change occurs, both of these will get rebuilt, right? It doesn't discriminate between these two. So that's a failed test case, failed scenario, right? So is there any other better way to do this? There is another way called scoped models. Scoped models. Now, scoped models is another simple technique to maintain state in your application. In this, what we do is that we have something called a scoped model, and we have something called a scoped model descendant. Scoped model descendant, SMD. Okay. Now what will happen is that this scoped model descendants will be like listeners to this particular scoped model. Whenever the state changes here, this will get reflected across all the descendants. All the descendants will be listening to that particular scoped model, and whenever the change occurs in the state, it will automatically try to reflect that particular state change as well. This is another useful model, since the state is propagated through the widget tree only to the particular descendants, right? But this again, here again, whenever the change occurs in the state, all the descendants get rebuilt, right? This is another load to the application. So in order to maintain state effectively and to use a better way of maintaining state, that's when we go for this business logic. That's when we go for this business logic component pattern. Here everything is a stream, right? The input events are streams, the output data are streams, and listeners listening to only those specific streams are notified. The other listeners are not at all. I'll give you an example, guys. Rather than trying to talk too much, I'll give you an example so that you understand it in a simpler way. Consider a chat application. Okay, I have 5 friends. I have say for instance, I have 5 friends. Now I am chatting with one of them. Say for instance, I am chatting with the third guy. He is sending me messages, I am sending him messages as well. This is a one-to-one chat. Now this chat, is it not visible here? Here I have too much real estate, whereas I am trying to cram everything this side, right? I'll redraw this quickly this side. Okay, now you understand what I am trying to say, right? I am having a simple one-to-one chat, and whatever chat message I am sending is sent as a input stream event. This is processed by this particular business logic component and shown on this particular user screen, since the user is listening to the output stream of the business logic component into which my data is sent. So we are having this one-to-one chat. At the same time, another user, say for instance this first user, is trying to send me a new message. Okay, so what will happen in this case? In this case, there will be a new message notifier listener here, which will be listening to the new messages that are appearing inside this business logic component. It will pick up this new message and show that you have received one message from this guy, or you have received two messages from this particular user. It will show me a notification like that, but that will in no way affect my one-to-one chat with this third guy, right? This will be happening smoothly, whereas my new message notifier will pick up this new message that is being sent from the first user and then show it up on my screen as you have received one new message, right? So this is exactly what's called reactive programming. We react to the events that are happening, changes that are happening inside your application. No, not we. Your application reacts to changes that are happening inside the application itself, the logic of the application itself. How does it react? It uses streams. Streams are nothing but events or data that is arriving over a period of time, and whenever a particular stream or a particular data arrives, it looks for the logic corresponding to that particular stream and updates the application accordingly, updates the state of the application accordingly. This is called reactive programming, and this exactly is called the BLoC pattern or business logic component model. Now what I'll do is, this is simple in concept, guys. It's a very simple concept, but when you try to implement this in your Flutter applications, you will need some basic logical skills to do this. So what I'll do is, in my forthcoming videos, I'll try to show you one or two simple examples with implementing this BLoC pattern in your application, and show you how reactive programming can be effectively used to manage state even in your large applications, even in a very large application. Okay, now back to what we were discussing. Hope you now have an idea of BLoC pattern, guys. I think I covered pretty much the very basic stuff there. To bring this inside your application, the concept is really simple, guys, but to bring this inside your application, your Flutter application, you need to use your logical skills, okay, in order to determine how it's going to be implemented using that. Okay, that is in your Flutter applications. So what I'll do is, in the coming week, I'll post one or two videos showing simple implementations of this BLoC pattern inside your Flutter applications. Okay, now let's move on to our next part of the show. In in this episode, I wanted to give a shout out to this particular article. This is something I saw yesterday, guys. And since we were talking about block patterns, I thought this would be an appropriate article to show you guys. This is a well written article in which the author shows us how to change the application, change the theme of the application dynamically. Right? I told you, right? Streams are stuff that's happening over a period of time. So this guy, this author, what he does is that, this developer, what he does is that he shows us how to change the theme of a application dynamically, that is using the block pattern. And this is a well written article. He has started out from the very basic, and he has written it in a pretty much elaborate way, covering all the important stuff that needs to be discussed while we are talking about block patterns. So I thought I would give this article a shout out in this episode. Link to this article will be available in the description below. And once again, thanks to the author of the article. What's his name? Jorge, I think it's pronounced Jorge Coca. Yeah, thanks to Jorge Coca. So yeah, guys, finally we have arrived at the end of the episode. Hope you like this episode. A large amount of people have started to watch this FlutterBeam series, and I'm really happy about it. Hit thumbs up if you really like this episode. Subscribe to my channel if you want to watch more cool stuff like this and other videos regarding Flutter as well. I have prepared a large amount of videos on animations, guys, from basic to bringing really cool animations inside your applications. Around 7 or 8 videos, I think. I was planning to make it as a course and then sell it, but rather than doing that, I am thinking of uploading all those videos onto YouTube. So kindly subscribe to my channel to watch more cool Flutter stuff like that. And yeah, I'll talk to you guys in my next video. Bye.